Hey everyone, what's up? Are1or0 here. So today we're going to talk about Kubernetes security. First of all, I'm going to give a bit of introduction of what is Kubernetes. We're going to talk about different components, different core pieces, and then after giving the enough description or introduction, I'm going to go through this intentionally vulnerable cluster environment. There are different vulnerabilities. We're not going to cover them all, but we're going to talk about some of them briefly. And do some of the exploitation. I will go through first Kubernetes original website and the documentation. I also created some very immature diagram here in my Figma page, so I will also go through that. Maybe visualization can help, but there are better documentation here as well. I'm just gonna show the way. If you're ready, let's jump right in. So just to understand, what is Kubernetes? In the simplest words, Kubernetes is an open source container orchestration platform. So what does it do? It basically automates the deployment for scaling and also management of the containerized application. If we're not familiar with containerized applications, Docker, image registry, etc., I would definitely suggest you to go check it out, because then the rest of it will be not familiar to you. So try to figure out what is containerized applications, what's Docker, what are the images, and and yeah, for the short version of Kubernetes is written like this, K8s. So that's something also to keep in mind. There's a really cool documentation to see the overview of it, comparison, basically traditional deployment, what does it look like with the application, the operating system, hardware. After that, there was more virtualized deployment. It's a hard rate operating system, a hypervisor, like VMware's hypervisor, etc. And then the virtual machines. Instead of one machine with just an app running, we were having instead virtual machines with apps, binary, library, operating system, all of it like that, to save resources and expense as well. And then the container development comes, and what does it look like? Instead of virtual machines, we're basically having containers. There's pods, etc. in it that we will talk in a bit. So it compares what's the traditional deployment environment, what are the positive parts of the containerized deployment environment, etc. So this is a great resources. Just to clarify, I'm not a Kubernetes expert or something, or I'm not DevOps person, I'm not an infrastructure engineer. I just know it enough for me to understand the security aspects of it. So definitely go check it out to learn more about Kubernetes. Okay, so let's talk about the Kubernetes components. Like I said, the diagrams here are much better, but I just created in my own understanding to see what do we have here. So in summary, there are two core pieces, two core components of Kubernetes cluster. Imagine this a cluster. There's the first one, control plane. There are different core components of the control plane that I will explain in a bit. But in summary, control plane manages the state of the cluster. So for instance, in production, it runs on multiple nodes, which will span across several data center zones. And this is basically having the master processes. It's very important for the overall Kubernetes cluster. And the second component is set of worker nodes. Basically, they run the containerized application workloads. And each containerized apps run in a pod. I will explain it in a second in a bit. And there are other components in a node as well, which we will talk about. So overall, there's a control plane that basically is the mastermind that's manages all the processes and all of the infrastructure basically. And then there is the real infrastructure, all the data, all the resources. That's why it's much bigger, higher workload, etc. So you can think of it like that: the brain and the body. Okay, in the brain, what do we have in the control plane? There are four main components. The first one is API server. In summary, the API server is an interface between the control plane and the clusters. So that's the main goal of main purpose of API server. And then there is controller manager. It basically runs the controllers that manage the state of the clusters. And then there's a scheduler. It schedules the pods onto the worker nodes in the cluster. And it makes placement decision based on the availability of the pods and the nodes. And the last one is etcd. Basically it stores the cluster's persistent states. It stores and retrieves the information about the clusters. So these kind of components that he has. So as you can see, this is like the brain, this is the mastermind, and it has different components that covers different areas, like the having the interface between the control plane and the clusters. Some of them stores the cluster persistent states, retrieves information about the clusters. Some of them schedules the pods onto nodes, make placement decisions, runs controllers, etc., etc. So they all have like different management responsibilities basically. For the worker node, for the second part of the Kubernetes cluster, there are also main components here. So let's see it like that. There are multiple nodes and everything. I just like break it down here so that we can see it in a like bigger format instead of squeezing it all in one diagram. So what do we have in a node? First of all, what is a node? You can think of node as the virtual or physical machine, and it has multiple components in it. One of them is pod, which is the smallest unit in the Kubernetes. The pod, you can think that it's the abstraction over container. What does this mean? It basically creates a running environment on top of the container. It generally has one app per pod usually, and each pod gets their own IP address. So if one dies, the other one is created immediately, and the new one gets a new IP address, which may be problematic from the configuration perspective. That's why there are like permanent IPs in use as well. Anyway, it's not relevant to us right now. What else do we have in the node? So there's something called kubelet that's very important. It basically ensures the desired state of the pods is maintained. It gets instruction from the control plane about which pods to run on which node. And yeah, it's basically a daemon that runs on each worker node in a summary. Yep. So what else? Container runtime. I mean, the name's just itself, right? Container runtime. So it runs the containers, pull images, starts, stops container, overall manages the container resources. And there's something called kube proxy. It's also a network proxy that runs on each worker node, and it routes traffic to the correct pods, basically, based on the configurations. So that's like the overall picture. It's definitely given better in here. And it also explains in much detailed manner what are these main components, what do they do, etc. So in case I missed something or couldn't explain it properly, just go check out the documentation on the Kubernetes components. Kubernetes API, we're not covering it right now, but you can also go check it out. The objects in the Kubernetes, of course, you can go check for more details. We're going to talk about the YAML files now for the Kubernetes configuration. But overall, like, why do we use Kubernetes? Different positive sides of it. You can also read it in here. Why Kubernetes? Why not? In summary, basically, it provides you high availability. If one pod dies, one container dies, basically everything is replicated. So you don't need to have like runtime issues or downtime issues. It's scalable. It gives you high performance. You can definitely like create an environment, a container, a pod, by just like creating the configuration and like spinning out like that. From disaster recovery perspective also, it's very smart. So there are a lot of cool sides of the Kubernetes environment infrastructure, so go check it out if you want to learn more about it. Okay, what else do we need for the rest of like the security perspective of it? Let me think. So pods, basically they communicate with each other via services. And what is a service? Service is a static IP with a DNS name. That's one thing to know. There are two files for configuration. One of them is configmap. It has the external config of the application, like the URL of the database and other services, like non-confidential data basically. And the other one is the secret file. So secret file is just like configmap, but it stores the credentials or secret, etc. It's encoded, encrypted as well. On top of all of these, of course, there is like the volume, which attaches a physical storage. There are different terms like deployment, stateful set, etc. I would recommend you to go check out. But I think overall we understand like what is Kubernetes, why do we use that, what kind of main components do we have that we will use later. So there are a couple of tools that we will use. One of them is kubectl. It's basically used to create nodes and other components for the Kubernetes environment. And then the other one is Minikube. It's an open source tool, and it basically runs master and node processes. These are the tools that I'm gonna install. So what do we need basically here in our local setup? We need multiple masters, multiple worker nodes, and separate virtual machines. So what we're gonna do is, what's that? A GitHub page that we're gonna go, and we're gonna clone this. First of all, let's see the prerequisite. What kind of tools do we need to use? We need to have, so kubectl it asks for, we have it. I installed Helm already. It's just like having one command brew install Helm, so there's nothing crazy about it, just go for it. So yeah, let's clear this and let's clone here, change there, and then of course change the permission of the file. That will allow me to set it up, and let's say say Minikube start first. I forgot to do that. First we do the Minikube start to create the environment, and then after that we will run the setup, and it should work then. So as you can see, kubectl is now configured to use Minikube cluster and default namespace by default. We basically prepare the Kubernetes on Docker, and now we are gonna create the setup. It's going to create all of the pods, nodes, etc. for us, and ensure pods are running in running state before running access Kubernetes. SH it says, so we will say this kubectl get pods. It's not in the running state yet, so let's wait until it's done. Still container creating, completed one only, one running. Let's wait a bit until they're all in the running state, and once we have that, we will just run access Kubernetes Goat sh command, which will allow us to navigate to localhost 1234 port, where we can see all of the scenarios. So let's wait until all of them are running, and then we can run this comment. Perfect. Let's run this comment, and let's get started with the first scenario. So since we set it up, let's start with the first scenario. But before that, let's give an introduction of what is Kubernetes Goat. It's basically a security learning playground. If you watch my previous videos on the API cloud security, I use different playgrounds like that. This is for the Kubernetes as well. So it's intentionally vulnerable by design. There are different common misconfigurations that you would see in a real world scenario, and it's implemented in here, different security issues in the Kubernetes clusters, containers, or the cloud native environment. It's not so easy to understand Kubernetes because it's very complex. There are so many different components, but this basically summarize most of the common scenarios that you will see, misconfigurations, and it's a great learning opportunity for security engineers or anybody that's interested in Kubernetes security. So we will start with the first scenario, which is sensitive keys in code bases. In the scenario, basically we focus on a popular misconfiguration that's done by developers or DevOps teams when they're packaging the artifacts and application code base. For more information, of course, go check out the Kubernetes Goat documentation. It's perfectly written. I really like it. So yeah, let's get started. Once we spin up the environment, it basically tells us like where to reach out for each scenario. The first one, sensitive keys in code bases, and that's the URL and the port that we will reach out to, localhost 1230. When we go there, it mentions that welcome to build core service, code service. The service is built using containers with CI/CD pipelines and modern tool sets like Git, Docker, AWS, and many others. So you're seeing that, and you don't have any like menu or any endpoints that redirects us to, and like what kind of things we can think of. If we think like the simplest, we know that this service was built using CI/CD pipeline like Git. There's one thing that you're probably most familiar with from all the CTFs and like the hacked box missions and everything, when you know that the infrastructure uses Git. What do? You go to the endpoint.git. Of course, it says cannot get Git because you need to give the full endpoint under Git as well. One thing would be config to see, to verify that a Git configuration is available. One thing we can do at this point is we can download a tool called Git Dumper or something like that. We will just basically clone the repository on our current working directory and download the Git repository folder for the further analysis. So how are we gonna do that? That also shows like the installation phases and everything. It's like pip3 install Git Dumper. Do that, and once it's downloaded, you can use Git Dumper with the following syntax. You can also just type Git Dumper and wait until it gives an error message to see what kind of syntax you will use. It's basically Git Dumper and then the URL that you're gonna grab the repository, and then the name that you want to name it basically. So after we download this Git repository, we will go to that folder and let's see what do we have there. Of course, the first thing we can think of when you download the Git repository is we can check for Git history and information, and we can look at the logs by doing that. So the comment is git log for that, and you can see on the previous commit history basically. There is a specific commit that looks interesting when you see the comment like the custom environmental variables, and we will check out that specific commit, and you can use the command git checkout and then the value for the commit, and then this will basically bring the environmental variable to our current working directory. Perfect. So when we read that file, as you can see, we found the AWS credentials, key, access key, secret key, etc., and then the flag as well, since this is CTF. That was the first scenario. The next scenario is DIND. It's basically called Docker in Docker exploitation. So while using the scenario, we can learn how to test and exploit the container Unix socket misconfigurations, and let's see what's waiting for us. We will go back to the setup page, which shows us which scenario is accessible via which URL or which comment, and we are accessible here with the port 1231. So let's go there. It also gives a brief introduction. Basically, we know now that we are using Docker is used in the background, and we will use different exploitation steps on that. So when we go there, we found a website that says ping your servers, and obviously like you're entering your IP address or server address that you want to ping. So I'm assuming that the comment in the background is ping and then the IP address that we're inputting. If there is no input validation, probably we can actually turn this into an RCE by just adding a semicolon and any other comment that we want. First, we wait a bit. Of course, ping takes a bit of time, and we will see the response output in here. I'm suspecting that's the case, so I will just I'm just writing down here what's the syntax in the background, probably ping, and then the value that I'm entering. So just write the IP address and the semicolon, and then write any other comment, like who am I, for instance. When we run that, we're going to get the output as root. We're in a container, and we are able to do RCE using this functionality, or ID, or any other comment that you will run. So what we can do here is the following. We can run mount comment to see if the docker.sock is included in the output, if it's available or not. And we will see that custom docker.sock is mounted in the file system. So we are assuming that it's mounted from the host system. This is just one exploitation technique on Docker. It doesn't necessarily be the case, but it is the case here. So what we can do is we can basically check the current system's current operating system details with uname -a, and we're gonna see that the target system is running 64-bit Linux box. Then we will go to the Docker website and download the stable binary. With the current version, I will download latest version for 64-bit Linux box. Just go to that URL, Linux static stable, and then go for the subcategory 64-bit. It will give different options to us. And then choose the latest version. It's gonna download the tgzip file. We need to unzip it. We can use wget comment to download the file, not to my current system, but let's copy the link and use the RCE to actually download it to the container. So I'm gonna say again semicolon wget in the URL that we are downloading the compressed file, -o for the output file name. So it's going to be under temp directory, and then the same Docker name, same file name I can use. Let's submit that, which will download the file and save it there. I'm also running ls temp to see if it's downloaded, which it did. And then I will uncompress the file, decompress the file with tar command under temp again, and the target directory will be temp as well for the decompressed file. Once we decompress it, basically I can access to the host system by running a specific Docker command by passing the docker.sock Unix socket. Perfect. Now let's run Docker, and as you can see, the binary is under Docker folder again. So we will go to temp, Docker, and then the binary is Docker. And you can check the documentation how to call the Unix socket, basically, docker.sock, and that's the syntax for it. So we will use the following: -h unix // custom docker.sock. That's where our docker.sock was given in the beginning when we checked with the mount command. And then we will check for images. When we run this, we can see container images in the host system. Cool. So the third one is an SSRF vulnerability in the Kubernetes environment. So you have to exploit SSRF vulnerability in applications and cloud environments. We will query the metadata, gain access to the cloud provider data, and basically leverage Kubernetes service discovery feature to do the exploitation. So it's also given a summary in here. We will just go to that port to start exploiting the vulnerability. So the website is basically internal API proxy. You enter your endpoint and a method and a custom header if you want to. What I'm going to enter is my endpoint. I'm going to write my local host with HTTP. Method, I will write git. So I don't know which ports are running here. Basically with the SSRF, I will figure that out. I will submit this and I will get this request in my burp so that I can do some attacks with the intruder. That's the example output you see. So let's intercept it with burp. For instance, I'm just running the port scan basically on port 22 to see what kind of output I get. If the port is not open, you just get an empty output. So let's send this to intruder. First intercept the request and then send the intruder. Here we go. And let's do a port scan for any port that may be open. So once we do that, we will find one open port, 5000. As you can see in here, the length is different for the port 5000. So we're going to just send this to repeater so we can try to extract some information. And what do we see here? When we send this request, it returned an HTTP response, and it's mentioning refer to internal metadata DB for more information. That's the host name that we're talking about. So for endpoint, I will send this instead of my local host. And when I send that, it's gonna give me various endpoints like latest. When I see latest, it's already giving me metadata API endpoint that's known. So I'm assuming that's gonna give me like some secret at the end of this. So let's attach a slash at the end of it to get the output. Perfect, latest, and then we will continue enumerating with the key values until we reach out to a flag, until secrets and Kubernetes Goat. Here we go. It's a base64 encoded flag, so it's nothing crazy. You will just go to your terminal and use base64 tool to decode it with echo-n encoded value pipe base64-d. So that's basically one way to exploit the SSR vulnerability to grab metadata API secret, basically. So nothing crazy, but just another technique. Cool. So the next one would be Docker CIS benchmark analysis. So this is not an exploitation one, also the next one as well. It's basically showing you how to perform CIS benchmark audit for Docker containers. So no exploitation included, it's just showing you how to use some comments basically. You can also see that in here it says the scenario is mainly to perform Docker CIS benchmark analysis on top Kubernetes nodes to identify possible security vulnerabilities. So we will just run the following comment to deploy the Docker CIS benchmark, and then we will execute into the pod. Okay, so we run that initial comment to deploy the Docker CIS benchmark, and then we will list the running pods with the comment kubectl get pods. And you're seeing it in here, the Docker bench security something. And we can just access it by running the command kubectl exec -it, which is interactive, and then the Docker bench security pod name. So yeah, the Docker bench security is already installed in this container. So you can just navigate to that directory and start the scan with running Docker bench security sh file. It will give you a bunch of output like with the warnings or like formatted stuff. And based on the vulnerability, basically, you can proceed with the further exploitation. That was one way to start the scan. The other one is basically Kubernetes CIS benchmark analysis, which we will see in the next example. So this one's very similar to the previous scenario, and the way that we will run it is very similar as well. We will deploy the Kubernetes CIS benchmark with the kubectl apply command. The different YAML files are given in here. Any of them should work. Let's start with that. So once it's created, we can get the list of jobs and associated pods information. First by running kubectl get jobs command, and after that we can also get the pods to see the status running, etc. So once we identify the pod, then we can get the audit results basically with the kubectl logs. If you run that, we will start seeing the vulnerabilities, and based on the vulnerabilities, of course, you can proceed with further exploitation. It doesn't cover it in this scenario. It just shows you basically the audit side of things, not just exploitation, but actually how do you reach there in the first place. So the next example is attacking private registry. Let's see what we're going to do here. It says basically container registry is the place where all the container images gets pushed. Correct. Most of the time, each organization have their own private registry. Also, sometimes it ends up misconfigured, public, open. On the other hand, developers assume that it's internal private registry only and end up storing all sensitive data here. So let's see what we can actually grab from here. We navigate to the local host, port 1235. And yeah, let's see what we're gonna get here. So there's nothing in the website. So how are we gonna figure it out? Since we know the scenario related to Docker private registry, container registry, we will go to the endpoint we see in the Docker API documentation, which says basically v2 for the versioning, and also underscore catalog, which can allow us to list all the repositories. So that's what we're gonna do. When we check like that, we're gonna see different repository names, like 2 of them, got alpine and got goat users repo. So I can go to that repo, but I need to still add more endpoint based on the API documentation. That would be manifests. So the tag would be basically the latest, and as you can see, we can download all the information like that. Of course, we can also use curl so that we can see all the output as std out instead of downloading the file. So let's go to terminal and download it with curl. When I get that, I think I did a typo. It should be manifests instead of manifest. So when we do that, we get all the information, and you will see on top, if you scroll up a bit, that environmental variables contain the API key information. Again, it just shows a misconfiguration. It doesn't show like a full CTF scenario or like full exploitation. It's just like where you can find different vulnerabilities based on the common misconfigurations. So for now, that was all, because the video gets really long otherwise. So in the beginning, I gave an introduction of what is Kubernetes, what are the most common components. Like I mentioned in the beginning, it's a disclaimer. I'm not a DevOps engineer, infrastructure engineer. I'm not that deep on Kubernetes. I just know it enough for me to understand the security misconfigurations and exploitation phases. I'm still learning, so that's a disclaimer. But that basically summarizes most common attacks, most common misconfigurations, and how to exploit them, or how to do the auditing phase basically to start the scans, etc. So I hope you enjoyed the video. I think I may create another video on this one, Kubernetes Goat. It's quite cool that the documentation is also great. That shows a lot of resources for you to also learn further steps. So I may want to create another video, or I may look for another tool, vulnerable platform, playground basically, to learn more about Kubernetes security. I hope you enjoyed the video. Just drop a comment and see you in the next videos. Cheers, guys.